Welcome, fellow teacher, to Data Games and to the game called Proximity. This game is all about direct proportion. The distance that the ball goes is directly proportional to the amount of pullback I give it, in this case 11.5. You don't want to tell the students that. You want them to figure it out for themselves and then to use that direct proportion in order to get a high score in the game. You may need to introduce a couple of tools if students don't get them from the instructional video or from exploring. For one thing, they'll need to measure distances from the ball to the goal. If I click the ruler icon, I can drag and see how far it is to my goal, 146. So then on my next shot, I can see whether the amount that I pulled back was too little or too much for 146. The trouble is, I couldn't tell how far it actually went. Fortunately, the computer records all the data, so I need to look in the table. For that previous shot, I pushed it at 7.8 and it went 78 units. Students who look at this might notice there's a factor of 10 between the distance and the push. So if I measure my distance and I find that it's about 95, and then I pull back about as close as I can get to 9.5, Shazam, I'm right in the middle. At this level, called Doc, some students will use the table almost exclusively to figure out what's going on. But once they move up to the next level, called Sneezy, the graph is going to help them a lot. You have to score 500 on Doc to unlock Sneezy. Click on Sneezy in the Levels box to move up and start a new game. This time, the ratio isn't going to be an easy number like 10. So, I clear my data to get rid of the old game and do a sample shot or two. The default graph shows how the distance I travel depends on how hard I push. If I put a line on the graph, I can even lock the intercept at 0 if I realize that's appropriate. I get an equation that will help me. I measure the distance. I know that. So for a good shot, I need the push, which means I have to divide by the slope to get what I need. For example, I need to go 146. My slope is 3.07, so I divide and get 47.5 for my push. I pull back as close to that as I can get, and look, I got 98 points. But after all the messing around I did, there's no way I'm going to get the 425 points I need to move up to the next level in 6 shots. Students need to use the line immediately, right after the first shot. Let them figure that out for themselves. You can, however, ask some good questions to check for understanding and to propel them forwards. My favorite opener is, how did you decide what push to give the ball? You could also ask questions like, what can you tell from the graph? Or, how far do you think the ball would go if you could give it a 0 push? You can't actually do that, by the way, but that's okay. Or, you could ask, how many balls do you need in order to decide where to put the line? The answer to that one is only 1. In your class, you may have various goals for your students, but one good one is to unlock the Dopey level. To do that, students need to beat the Sneezy level twice in a row with 425 points. We find that getting 425 twice in a row usually means you really had to do some data analysis and be pretty careful. As you advance to higher levels, of course, things get more complicated. One more thing. If a ball bounces, the distance the computer records is the distance from where you started to where you ended, the straight line distance. That will make points that don't fall on the line. This is another chance to probe for understanding. What does it mean that this point is over here? A feature that will help. Drag and bounce to the middle of the graph. This technique, which we call adding a legend attribute, gives you a lot of interesting display options, especially as games get more complex. Good luck!